Okay, so I'm going to power on the inverter and to test the sine wave to see if it is pure connecting with a scope. This is a little tricky here. I'm using a 3 resistor. I calculated the watts so they will not burn. So now you can see, wow, pure sine wave, 50 Hertz. You can see the voltage 10 volt, which means exactly 220. And now I will power on the 500 watt fan and check if it consists sine wave because it's more power. Let's see. Amazing. This inverter very good because the sine wave is pure. You can see no problem, and even with 500 of a load it's act great. So very pleased with this one. Okay, now I would like to check the efficiency of this inverter. So we will read what is written here in volt. We have the current here on the current meter, and then we have the power. And now we will use this fan again and activating the fan. So we can see 476 watt. We have here 515 amp and 35.5 volts. Okay, now we can do the calculation. Okay, now I want to go to a higher watt rate. Okay, I will use around 800, a little more. We can see how the battery handle it and how the efficiency is. So starting here, the fan. (862 watt), 26.7 amp. And we have 33.8 volts, but we can see no issue. We can see that the battery and the load and the inverter, it's only a few seconds, but nothing get hot and everything works perfectly. Okay, so I was asked about how to choose the inverter, so I will try to explain it. So in inverter you have some basic parameters that you need to take into consideration, and the parameters are the battery that you are going to use, okay, the appliance or the instruments that you're going to supply power for them, and the inverter itself. Okay, so now let's go for the inverter. In the inverter you have some basic parameters that you need to consider. First will be the voltage in, and you will get a range. The range will be something between minimum to maximum. Why is that important? Because this is the battery and the batteries that you are going to use. In the inverters that I bought, you can see that on the model with 36 volt, the battery will be between 30 volt to 45 volts. And other thing you can see here, of course, will be the voltage out, very important. Usually you want to be or 100 volt AC or 220 volt AC. There are some other like 380. And then you want to consider the protection type. The protection is very important to protect everything, to protect you, protect your instrument and your battery. So we will have usually over voltage and under voltage, okay, and under also. and short circuit protection. Short, very important, short on the output. And also you have temperature, which means if it is going to be up above something, it will stop everything. And the load overload, which means when it will stop to supply power out. About your battery, and of course I didn't talk of, but you have also 50 Hertz and 60 Hertz, depends on your voltage and state. And another thing about the inverter, what I talked is the efficiency, very important. Efficiency, and the efficiency is usually depend on how it works, if it is sine wave or modified sine wave or square wave. Okay, so you have few options. Square wave is not very good, but it will work. But it will work without taking less power from your battery. The most efficient is the sine wave. And also what important is, of course, the power out of the inverter. The power out means how many instruments you want to be able that they will work all together. For example, if you have 2000 watt, so all your appliance and instrument can be up to 2000 watts. And now we're going into the battery. Very important. The battery is the battery that is the input for the inverter. And also in the battery, you need to know the voltage range of your battery. What is the voltage range? It is going like in the inverter from minimum to maximum. Maximum is fully charged, minimum is fully discharged. Also the BMS of the battery is very important, battery management system, because the BMS tells how many current continuous you can draw from your battery. For example, 30 amp. And if your battery, for example, nominal voltage is 66 volt, so the power out of your battery maximum will be, of course, I multiplied by V, or 30 multiplied by 36, which is probably around 10,000 watts. So this is the maximum power that your battery can get out. So if you're using an inverter of 2000 watt with a battery of 1000 watts, so you're limited. You will not be able to work on 2000 watt load. Another thing is the capacity of the battery, of course. The capacity is how much time it can deliver the power out. Capacity is usually in ampere hour or in watt hour. And watt hour is the nominal voltage of the battery. Okay, so watt hour will be nominal voltage of the battery multiplied by its capacity. Capacity is ampere hour. So for example, if you have a battery of 36 volt nominal and the capacity is 10 ampere hour, so you have maximum 360 watt hour, and this is the maximum watt hour, which means you can supply to your load maximum 360 watt for 1 hour. And if you will supply twice the load, for example 70 20 watt, so you will be able to work just half hour because you are limited by your battery. And of course, what is important is the current out. The current out is the maximum current that your battery can deliver, so everything work okay. Okay, so we have the inverter and the battery, and now the instruments that you are going to work with. For the instruments, you will have, for example, a TV. I measured a TV of 49 inch that I have, and the power out is 70 watt. So this TV for 1 hour take 70 watt from the battery. If you are using, for example, refrigerator, so if it is just frozen one, usually less current, or regulars, you have frozen and not the frozen. So it's about let's say about 150 watt, but you need to know that you have defrost. For example, I read on my refrigerator in the defrost mode, it consumes 220 volt, and the current is 2 amp, which means I need to deliver, when it is doing the defrost, 440 watt. And some of the refrigerator are not inverter, so when they are starting to work, so the power consumption can be twice than the rated. So if it's an old motor, the starting point consume much more energy, and if your inverter can deliver it, so it will not work. About LED, if you have LED lamp, let's say a very bright one, 40 watt, so it's 40 watt of power consumption. Laptop usually depends on the laptop, but it can be around 100 watt maximum that you supply from your power supply to charge your battery. And if you are charging a scooter, for example, so the power will be 100 watt till 150, maybe sometimes a little more. So let's do an example for this. Suppose I want to work with refrigerator and TV on emergency and 2 lamps. So I need to do the calculation. The calculation is very simple. So if the refrigerator, we wrote 100 and let's say the refrigerator is small and used just 100 watt. If it is frozen or other, some of the refrigerator are 100 watt continuous. So if we have refrigerator 100 watt plus TV 70 watt plus 2 lamps multiplied by 40 watt. So the total in this case will be 100 plus 70 plus 2 times 40. So it's total 250 watt. Yeah, if I'm not mistaken, yeah. So this is not the calculation, because we need to know that each inverter efficiency maximum is about 90%. So we need to take this number and divide it by 0.9, and then we will get, let me calculate, yeah, we'll get 278 watt. So in order to work with these sinks, to get them to work, we need this amount of power. And now if we have, for example, 1 kilowatt of battery that we bought, and we want to check how much time we can work with these sinks, refrigerator, TV and 2 lamps, we take this number and divide it by the number that is needed to supply. And then in this example, it's 3.59 hours. And if we will go and convert it to real hours, so it will be 3 hours and 35 minutes. How do I do the calculation? So I take, of course, 0.59, multiply by 60 minutes in an hour, and we get 35 minutes. So this is the basic calculation of the inverter. So you need to take care to see that your battery can supply the power to the inverter. That the inverter is, we want to buy a pure sine wave because it is the most efficient. If you are going till the maximum power of the inverter, so the efficiency can decrease a little. And also if you consume a very low energy, also the efficiency is not very good, it's less good. The nominal power will be the most efficient in the inverter. You need to define how much power all your appliances need, and then you can calculate with 90% of efficiency the maximum time that your appliance will be able to work. Hope it's explained something. Thank you and bye.